d. Number 2 is, it is, yay. Okay.
3. D.
Yeah.
4. B.
D. So let's talk about it, and then we're going to go through. So, yep, the absolute values of velocity automatically tell you total distance. Yep. Displacement is considered change in position. So, like from here to here to here, my displacement ends up being 2. Because, like, I'm only 2 steps from my chair, but my total distance is like
6.
That's why
yeah, exactly. So like if you take 2 steps forward and 1 step back, your distance is 3, your displacement is 1. And that is today's lesson. However, we're going to start looking at it with integrals. So what I did is, because Alex had mentioned that one of the things he struggled with on the AP exam is knowing what average value was which. Like, do you go forward or do you go backwards? We had the big discussion about velocity is decreasing. So I cannot take credit for this. I did not make this. I found basically a mathematical translation of terms in terms of physics terminology in calculus. Because, again, we don't all take physics. And what it means in physics versus what it means in here. So in terms of your big question, average velocity is integrating. And or slope, it depends on what function you are. If you integrate velocity and divide it by b minus a, that's the average velocity. Because the integration of velocity is distance, not position.
No, it would be distance over time.
It would be distance over time. The integration of velocity on a closed bound is distance, not position.
It's like the average.
So by averaging it, it makes it
Velocity equals d over t.
the average velocity. Just like slope of the secant becomes average velocity.
But that wasn't even like what the question was. It was just average rate versus average whatever is what we were talking
So
about.
Corey, to answer position, go all the way down 3 from the bottom. Position is IVP, which is, again, what we're focusing on today.
That was the problem you just did.
It's like what we just did. You have to take into account the initial. Where a particle starts, how much pollutant is in a lake, how many fruit flies are in the initial. I can't, that face was so great. So like that's your initial plus your change in distance. So do you see like the difference from average to that? So that's our goal really for today is let's interpret what we're doing.
So,
Have you gotten rid of them?
No, they're coming back.
What if
I thought we had them exterminated. They're coming
but in
back.
terms of like not asking for speed or just asking for.
We'll go back and look at the question you're asking about. I honestly can't answer because I don't know. Like I know which one you're referencing, but I don't know which one you're
It was
referencing.
number 2.
On the open-ended or multiple choice?
Actually, I think it was number 1 on the open-ended, and it was just part D or C. I think it was part D.
Guys,
Alright.
how do you watch TikTok with it Bluetooth to your car? In the morning.
My phone is plugged in, it's charging.
Yeah, you can staple a whole punch, Corey. You know where my stuff
I
is.
listen to my Bible in here, but I can't focus when the spam is in the car, so I just take the TikTok once I'm
It just seems like the sound coming out would be
Alright.
distracting me.
So displacement represents change in position. Displacement represents change in position.
Delta X.
2 steps forward, 1 step back. That's like the main example I always give. It's 3 steps traveled but you're only one step forward from where you started. So you've made progress, but only one step in total, because it's forward, forward, back. Let's look at that in terms of integrals. So to find displacement from point A to point B, it's the integral from A to B of velocity, which is equal to S of B minus S of A, where A is usually representative of what? S of A represents what? Initial position. So even if my S of A isn't at 0, what if I told you like S of 2? And then we go to 5. That 2 is still your starting point. It's whatever the lower bound of the integral is. And that's what goofed Corey up on the problem, because it started at 0 on the integral, but it doesn't mean you can't go backwards.
Yeah, that was stupid.
You can, I mean, this is a prime example of this goes 0 to -4. So that initial condition they gave you was with respect to 0, but stuff happened before the 0.
I always assumed you would increase.
Yeah, this
Same as
is,
Corey.
like, it's just numerically.
I know.
Not what it should
But that's
be.
purposely almost why they do that.
Then it should be negative x to 0.
So we say in order to find your new location, it's your new position is equal to initial position plus displacement. So that's a transformation of this formula to S of B equaling S of A plus A to B of V of t dt.
And that's just like that one problem.
Yep. It's IVP, it's FTC, it like all blurs and flows together.
The only difference from what we learned before is this has to do with like velocities.
Yes.
Before it was just like
Yes.
acceleration.
Like we're gonna be talking a lot more about like rates of change. So like we did related rates with derivatives, this is like the related rates of integrals. We're gonna talk about like rate in versus rate out. So like in the lake pollution problem you did last night, it was pulling pollutant out. So you were subtracting pollutant. To find total distance, absolute values. Anytime you see absolute values around velocity, it is total distance. Because what that's doing is saying any movement you went backwards, you are reflecting across the number line and making it positive. Any movement you went backwards, you are reflecting across the number line and making it positive.
As long as those absolute value things are not on the bounds, we should be alright.
Corey, if I don't eat your quiche on Monday, please don't be offended.
Do you have a quiche fan?
I had a really bad quiche last year, and I kind of haven't recovered.
I love quiche. It's good though.
Alright, suppose the velocity of a particle is moving along the x-axis is given by the function v of t equals 6t squared minus 18t plus 12 when 0 to 2 is our time. When is the particle moving to the left, moving to the right, and stopped? So if particle is moving to the left,
Velocity is negative.
velocity is negative. So we want to know when is v of t negative, because that will give me left. When is the v of t positive, because that will give me right.
Can we just make a number line?
The
Backwards
number
and
line
set
does
it
not
equal to 0?
count though on the AP test. Yes, that's how we're going. And then
I thought
v
that
of
said
t.
6 feet. Not left.
Oh, sorry. When v of t equals 0, it's stopped. So, if I need less than 0, greater than 0, and equal to 0, what am I going to do to my function?
So it equals
Find your
0.
zeros. Is it on the same
What can you do to 6t squared, 18t,
What,
and
3?
6.
Oh. Yeah. I was
a 3
thinking-
would still help, but yes, you can act like it. So factored form.
Minus 2 minus 1.
So the particle is stopped at what?
2
T
equals
equals
1 and 2.
Right.
Yeah.
And that 6 just goes away.
Yes.
And then don't we need to put this on a sign chart?
No, not a sign chart.
Yes, it's a sign chart.
Oh, that is a number line.
No, it's a sign chart.
It's
What?
both. It's both. It's a.
It's
She's
certainly not
doing
a
a
sign
sign.
graph.
Yes.
She's not spelling sign S-I-N-E. She's spelling sign S-I-G-N.
I would
Today
not
has been
say
a
sign.
spelling
I would
day.
not say sign, whatever.
That was a
Sign.
horrendous homonym.
That is
I
not-
knew
you
what
do
she
not
meant.
say sign graph. That a sign graph
When
is
I,
like this.
yeah.
I knew what you meant.
That's
All right.
not a sign chart. 'cause
What
a
is
sign chart is
What is
Chart is
happening
this.
between 0 and 1? So that's like plugging in 0.5. So 0.5 minus 2 is going to be
negative, it's positive.
0.5 minus 1 is negative. A negative times a negative is a. So from 0 to 1, the particle is moving.
Right.
Okay, what's happening from 1 to 2?
I'm gonna say it's decreasing.
2 minus 2 is
Negative.
Can't do 2.
1.5 minus 2
Negative
is
times
still
positive.
negative. So it's going to be negative,
But it could have been positive, correct?
Yeah.
theoretically.
That would have.
Theoretically, it could have been.
Okay.
After careful consideration.
So like your justification would be because the velocity is less than 0 from 1 to 2, the particle is moving left. Because the velocity is greater than 0 from 0 to 1, the particle is moving to the right. The particle is stopped at 1 and 2 because velocity is equal to 0.
I thought you
So
said
like
that
if it
was
asked you
not-
for a sentence, all of your answers and justifications to why a particle is doing what it's doing is with respect to the function given. So don't tell me that the particle is increasing on position and that's why it's moving left, because you don't have position.
Is that why I didn't get the points on
Yes.
the AP exam?
Yes, that's why I'm stressing this. Yes.
Just to make sure, instead of doing the greater than or equal to 0.
You can say is positive, is negative, yes.
I'm hungry.
Man, that sucks.
All right, find the particle's
As Alex.
displacement. Find the particle's displacement for the given time interval if s of 0 equals 3. So the time interval is 0 to 2. So that's the integral from 0 to 2. That's our rate 3. Of v of t dt, which
Plus
we
3.
know is equal exactly.
To S of 2 minus S of 0.
Yep. And s of 0 is equal to.
3.
So what is the particle's final position at 2? Manipulating that, s of 2 is s of 0 plus the integral from 0 to 2 of v of t dt, which is 3 plus that integral. Which again, you could pull out the 6 and integrate t squared minus 3t plus 2 dt. this point, I'm distributing my 6, because what's it going to do to the 3?
Cancel.
Yeah. So I would take 3 plus 6 divided by 3 is 2.
So
2 times
16.
8. And then I would have manipulated that to be negative 2 times 6. So 16 minus 12 is 4. 4 plus 3 is. So the final position after 2 seconds is 7. And it would just be units because I didn't tell you like meters, feet, etc.
Why would we not use absolute?
Because this is displacement. We don't, that
No,
object,
no.
oh, for the next one. Oh, because you can't absolute value by hand. You can only absolute value on a calculator. So if we can't absolute value by hand, what do we need to know about a particle's total distance to absolute value it algebraically?
Displacement in sections.
We have to do displacement in sections.
So from 0
So-
to 1 and then 1 to 2.
Exactly. So it's the absolute value when the particle is moving
Left.
left, because that's when it's going to negate my displacement. So that's why you needed to know when is it going forward, when is it going backward, and when is it stopped. So the total distance is going to be initial position plus
The integral from 0 to 1 plus the
That-
integral from 1 to 2.
exactly, no, not plus the integral from 1 to 2. Minus, because the integral would be below. So how do you negate a negative area? You subtract it. So if you want to take
Subtract the negative.
exactly, so like the integral from 0 to 1 would be above, from 1 to 2 is below. So if we want to make this area positive, we're going to subtract the area.
What if they're both
Because
positive?
it makes it a minus, which turns it to a, what?
If they were
Never
both
mind,
positive,
you wouldn't even have to, yeah, that's
You
okay.
Correct.
just use what you got.
Why couldn't I just put plus the absolute value of the integral?
Okay,
from
but
1
can
to
you
2?
absolute value an antiderivative? Can you absolute value
Well,
this as a function?
Why can the calculator do it, but I can't?
Because a calculator is a computer.
Precisely.
So it can be done.
So what you would do is absolute value your antiderivative, which we already knew. So I already found the antiderivative in the previous step. The antiderivative is 1/3 t cubed minus 3t squared plus 2t.
So we are absolute valuing
No, we're splitting it up into 2 integrals.
So the absolute value represents the total distance traveled. Like if they gave you a problem and this is what they gave you, you would need to find the zeros of that function and create 2 new problems.
Shouldn't it be plus 3 at the end? Because of the initial condition?
This is what I wrote last year. I was gonna redo it.
Or is the initial condition involved in the distance
Not for
traveled?
not for distance,
Just
because you don't care about where you started or where you ended. You just care about what you
The
traveled.
only way the initial condition matters is for position,
Correct.
to find out where you are.
Correct.
Do I have to rewrite out my integral, or can I just use it from part B and use a different evaluated sign?
You don't have to antiderive it again, no. Like you can go from here to there since you already know the antiderivative. Is this helping
I'm
for?
so confused why you would subtract that.
So like, for example, looking at her thing.
Okay,
say
no,
the
don't
integral
even
was
like,
4.
don't even think about the subtracting. If I told you I wanted the absolute value of velocity,
You just make everything underneath positive.
you'd have to flip this, right? So an absolute
I'm
value
confused when you say the word flip. What does that mean?
reflect.
across the x-axis.
Right now, the first interval is gonna be 4,
This-
so the next one's -3.
What is my
You
area?
can't
Make
just
it
add
positive
them.
3.
So what's S of 1?
Yeah, by
12 plus
subtracting,
2
you
is
do that.
14. 14
You're
minus
subtracting a
9
minus, which
is
makes it positive, that's why she said
5. So this area right here is 5. This represents the area or the integral from 0 to 1. From 1 to 2, the area is
How do we lose the 6?
Yeah, hold on.
Hold on.
Something's not right there. I'm looking at this and that's
Hold
not
on, hold
right
on.
now.
So 16 minus 36 is negative 20. Negative 20 plus 24 is 4. So now you have 4 minus, what did I just say this was?
Negative
5. So this is negative 1. So the integral from 1 to 2, if you would integrate this, you're going to get a negative area because it's below. It's equal to negative 1. The total distance traveled says, okay, I went 5 steps forward,
1 step back. So you
1 step back. How many steps did I take? Great. If you took the integral from 0 to 1 of 5 and you add to it the integral from 1 to 2, are you getting 6? No. So instead of adding the bottom integral, we subtract it. Because what that does is then say, this is negative a negative 1. So now it's 5 minus a minus 1, which turns it to a positive.
So instead
So
of
when-
just making that area positive, you're just subtracting each other.
Because it negates the negative without without making your math messy. Yep. Go ahead, Corcor.
Never mind, I got it, because I was going to say, if that's right, then B should be 4, but that was adding the 3. 4 plus 3 would get you 7.
Right, because
That was asking.
it's exactly what we just said. Like, it moved for the total position change is 4.
Halfway through the day.
But it's like saying, like, I started 3 steps into the race. I had an advantage.
So,
I have
if
so-
that would
I have
just ask for the
I have
particle's
36 energy drinks in
displacement,
my house.
would it be
It's like with
4?
the sales stuff when I got
But
all
since
the
it
wine
asked
and
what
all
its
that.
position is, it's
We were
now
drinking
3
drinking
plus
the
4,
sausage.
which gets you 7.
Precisely.
And when I do it,
Okay.
I don't know why.
Precisely.
I can't believe I can like.
Because displacement is this.
No.
Total position change is that.
Right. Okay.
So displacement, we have to have the initial, or we have to have a starting point.
No.
So that's what Corey kind of just said. The displacement of the particle was actually 4 units. Because like you know how its total distance traveled is 6, because it's 5 forward, 1 back.
Yeah.
So if I started back there, how many movements am I from where I started?
4.
So the displacement is 4, but that chair was 3 units away from the wall. So its distance from the wall is 7.
So where we started wasn't the original initial.
It wasn't 0, 0. It was 0, 3.
So the displacement would be 4, but the particle's position is at 7.
Correct. Because it started 3 units ahead. I know. That's why we kind of have to understand integration to be able to do this, because you need to understand negative area. You need to be able to connect it all. All right, so let's look at the next.
Oh, or can we just call it quits? This is gonna be a long video for Blaze.
He's not gonna watch.
Blaze doesn't watch it. I mean, I can't say anything because I wouldn't watch it either, but.
Well, I want to at least do
I'm happy
the
with
top of
that.
the next one because I want to get you the graph. We don't have to do example 3. So it says, what is the particle's displacement from 0 to C? So again, displacement,
It'd be 9
So you gave me
it would be 10 minus 9, which is 1,
plus 8.
plus 8.
So it'd be 9.
Correct. So displacement is 9.
So displacement is just adding up all the areas.
Correct.
And the distance would be like
This would be
making
27.
everything, taking the absolute value.
Yep.
27.
So this is 9. This would be 10.
Plus 9 plus 8.
Yep. Yep. What is the position?
I'm still confused on the displacement.
Displacement is
Displacement is if
everything.
you were just adding up everything.
Displacement is forwards minus backwards plus forwards.
Okay.
It is actual areas under the curve.
If I just add them all up. Yeah. And make sure if it's underneath, it's just negative.
10.
But this part is position,
So I
which
make
is
sure everything's
initial plus the area. So for A, S of A is equal to 10, because that's the initial,
Plus 10.
plus exactly 0 to A, which is 10, so it's at 20.
B equals
Now,
20.
you can take S of A and find B, or you can find S of B using the original, and then you'd have to do S of A and S of B.
No, I just take the 20.
So S of B is equal to the 20, which represents S of A, plus the integral from A to B now. Because it's not the integral, it's 0. It's A, because that's what we're using for our initial condition.
So it would be 11.
So it'd be 20 minus 9, which is 11.
Then you're just gonna add 8.
And then C is 11.
Oh, that's why I knew x is 0 is 10. That's why I was wondering where you
Got it. So then 11 plus 8 puts me at,
19.
so the particle started at 10 and ends at 19. What do you know about the displacement?
It's 9.
9.
So shouldn't it make sense that if it started at 10 and then it has a
yeah.
displacement of 9, its final position is at 19?
Yes.
Boom, light bulb. That's why I wanted to do it. And then the last part, approximately, where does the particle achieve its greatest negative acceleration? This is the graph of velocity,
So the steepest
the
negative
steepest part of the slope, exactly. So,
B.
Should
careful.
be 0 to B, but it's B is included.
And
That's
it's,
a positive acceleration.
and this is
That's
positive.
increasing.
Right.
So you need the steepest negative.
Wouldn't it be then?
I said here, I said A,
Yeah.
because to me this isn't as steep as that. Now, they might actually give you numbers. And then where does it achieve its greatest?
B.
B, B,
Yeah,
B.
like right here.